Well, welcome to our lesson on analyzing graphs of polynomial functions. Your learning targets for this lesson are to be able to graph polynomial functions and locate their real zeros, and also to locate the relative maxima and minima, and we'll talk about that in a couple of slides. So starting out for graphing polynomial functions, we're going to be looking at just using tables of values to begin with. And I'll show you in class how to use tables on your calculator to help you. And we're also going to use the information that we've already talked about with the degree of the polynomial, its leading coefficient, and the end behavior. And that's going to help us to sketch the graphs of these functions. So let's start off with an example. And in our example, it says to graph the function by making a table of values. Well, I already have a table of values ready for you here. So I've picked coefficients that differ by a half. Now, if you're not sure what values to put in for x, what I would do is put the function into your calculator. You know how to do that. Put that into your y equals. And then once I show you how to use the table function, you can set up your table to get these values and either go by single integers or by 1/2 for your change there, for your delta. Now in this example, the degree of our polynomial is 4. That's the highest exponent. The leading coefficient is positive. So we know that our polynomial is even, and the end behavior for an even polynomial with positive leading coefficient says that as x goes to positive infinity or negative infinity, the function always goes to positive infinity. So then what you would do is you would plot these points, and these are going to be approximations on your graph when you get things like 1.3 or 0.9. This is just a sketch, so just sketch those points. Kind of looks like a goofy W. So that's kind of what we're looking to do. Here's one for you to try. Go ahead and fill out the table and all the information and then sketch the graph. The location principle helps us to find where the real zeros occur for a polynomial function. And we've talked about this, but we just haven't labeled it as the location principle. And basically what we're looking for is a sign change. When the y variable goes from a negative to a positive value, when it crosses the x-axis, we know there is a real zero in between those two x values. So let's look at that in action. What does that look like in a problem? In this example, it says determine the consecutive integer values of x between which each real zero of the function is located, and then draw the graph. So first of all, we need to calculate what these x values are going to be. So if we plug in -2, we'll get out -32. -1 gives us -7. You're just plugging those in and calculating those. Again, you're probably going to use your calculator's table function to fill those in. And this time I went by integer values of 1. The degree on this one is 3. That's the highest exponent. The leading coefficient is positive. This is an odd function. 3 is an odd number, so this is an odd function. And my end behavior, as x goes to positive infinity for an odd polynomial with a positive leading coefficient, this should go to positive infinity, and with a negative, as it goes to negative infinity, it also goes to negative infinity. And then plotting your points, you end up with a graph that looks like this. Here's another one for you to try. Relative maxima and minima refer to points where in our polynomial function things change. We get a maximum value, but it's only a relative maximum because none of the points around it are bigger or smaller. So A is a relative maximum because there aren't any points, there aren't any y values around it that are bigger. And then B is a relative minimum because there aren't any points whose y values are smaller. So one of the things about our relative maximums and minimums is the number of turning points is always one less than what the degree of your polynomial is. So you can never have any more than one less than the degree of the polynomial. So if you have a fifth degree polynomial, you can't have more than 4 turning points. So here's what that's going to look like as a problem. It says graph the function, estimate the x coordinates where the relative max and mins occur. So first of all, we want to plug in our values into our function and get the outputs. And then we're going to take a look at those outputs. Now when you look at what's going on here between x equals -1 and x equals -2, we went from a negative value to a positive value, so we know this thing crosses the x-axis. So that tells us there's a real zero there. So somewhere between -2 and -1 we have a real zero, and it looks like it's closer to -1 because 1 is closer to 0 than -15 is. So it's very close to -1. And then if we look at our output values, we go from 1 to 5, so this is going up, then all of a sudden it's going down. So there's a turn that occurred here. So this tells us this is a relative maximum here at 0, 5. And then our y values, we went down to 3, and then it went down to 1, so it's still going down, and then all of a sudden it pops back up again. It goes up to 5. So you'll notice that there's a relative minimum here. 1 is a relative minimum because there are no other smaller values between those other values. So that's what that should look like. Let's take a look at the graph. So -2, -15 is way down here somewhere. So I'm just going to put this somewhere on our graph so that you know it's there. -1, 1. So the point -1, 1. It's right about there. And then we have 0, 5. I'll move this one. It's not where it should have been. 0, 5 is about there. 1, 3. Right about here. And 2, 1. Right around there. And then the point 3, 5. Back up here. Now our end behavior, this is a positive coefficient, odd degreed. So we know our end behavior is going to go to +infinity as x goes to +infinity. And then as x goes to -infinity, we'll go to -infinity. So it looks like we have, so this is going to come way down here, and bear with me because this is really hard to draw with this thing, so hopefully you can get an idea. So it's going to have a turning point here. We're going to go through this one, and we're going to turn around again and back on up, and this will go to +infinity from here. So we have a relative maximum here, a relative minimum here, and then our end behavior goes to +infinity and -infinity. Here's another one for you to try. That's the end of our video. See you next time.